Hello and welcome to another video. In this video we're going to be working on first completely painted row or column. And this one you're given an array and a matrix, and an array and a matrix both contain the integers in the range of 1 to m times n. So you want to go through the array starting from 0 and paint the cell in the matrix that has that same number, and return the smallest index at which a row or a column will be completely painted. So they show you this array, so this gets painted first, then this gets painted, then this gets painted, and so this is where we have a row and a column painted, so we want to return 2. And then the second example, so you paint this first, then the 8, then the 7, then the 4, and once you paint the 4, this column is painted, so you want to return index 3. So what they ask you is pretty straightforward, and basically how you do this problem is also pretty straightforward. The main thing here is we want to be able to paint things quickly. We want to be able to do two things quickly, right? So we want to paint quickly and quickly calculate. Did we paint a row or column? Because so this constraints matrix is 10 to the 5th, so you need like a linear solution here, or like n log n or something. So to paint quickly, like what's the problem with painting? Like what would be the brute force? Well, you would just take a number in the array and you would search in the matrix. So to solve this, we can pretty easily just make a map of number in the array to coordinates in the matrix. So essentially we can just go through the matrix first, take every number and then just write down its coordinates, and then when we go through the array we'll say like, oh, we're at number 2, where is that in the matrix? We can get this in of1 now. And then how do we quickly calculate if we want to paint a row or column? So the brute force once again is if we paint something, we're going to have to like go through the entire row or the entire column or something and check is that whole thing painted. That's not great. So the way to do this quickly is also a map of just rows and columns. And for every row and column, we can just have a count of how many cells did we paint. So essentially, let's say we paint this cell, or let's just go through example 2, I guess, as like the thing. So we're going to have a map of locations, and then we're going to have the map of row and columns. So we paint this cell 2. So this is at row 0. So the rows map will have some stuff, and then the columns map will have some stuff. So essentially, at rows 0, we can say that's the one we painted, right? So at rows 0, we painted 1 cell so far. And how many do we need to finish? So we need the number here to equal columns. Because if we painted columns number in a row, that means the whole row is painted. And the number here needs to equal rows. Because if we painted every single row in a column, that means the column is painted. So here we paint this, and also this is column 1. So we're going to say, okay, well, at column 1, we have 1 cell painted. But we don't have either of these met yet. Then here, this is row 2. So at row 2, we have 1, and column 0, we have 1. And we still don't have a solution. So then we paint this guy next. So this is row 2 again. Now we have 2, and at column 1 we have 2 as well. And the last one is 4, so this is at 1, 1. So at row 1, we have 1. We don't have the row painted, but here, now we have 3, and this does equal the rows because we have 3 rows. So then we just return the index we were at. So essentially, going to make a map of every single number to its location, and these 2, and then as we paint, we can paint in of1, and check if we have a row and column. Or check if a row or a column covered in of1. So let's do that. I'm gonna do these in Python for a while, just so I can code them quicker and live and stuff. So don't need this anymore. So essentially, we have the rows and columns, and then we're gonna have like locations, and this can just be like a list. And then we're also going to have the rows and the columns dictionaries. So equals, and these are both going to be this. So one and the other. Okay, so now we have to go through the matrix and then fill out this locations guy. So So we can just say locations of the number that's actually in here, matrix row column, equals row column. Okay. Now we're going to go through the array. So array. So we're going to mark this thing in the dictionaries and then check, do we have a full row or a full column? So rows, actually first we have to get the coordinates. So row column equals locations of this number. Now rows row plus 1, columns plus 1. So if rows row, so in order to have a full row, this needs to equal the number of columns, or calls column equals the number of rows. That means we have the full row or the column painted. We can just return I. And we can return something here as a default, but we should always have something painted. So yeah, I think that's it. Let's see. Okay. All right, and as far as runtime, I wouldn't worry too much about it. I guess you can't really do better than this. It's gonna be some small stuff. So this should be, let's think about it. So let's say this array is n and this whole matrix is m or something. So we're going through the matrix, which is m. We're going through the array, which is n. And that's it, right? Like this goes through the matrix in linear time. This goes through the array in linear time. Space. So we have this location. So for every cell in the matrix, we have a location. So that's m. And then we also have this rows and columns thing, which is going to be less than the matrix, because like this is the whole matrix and this is just basically the number of rows and the number of columns. So that's going to be, yeah, it's going to be less. So if a matrix was like x by y, it would be like x plus y, but this is going to be the higher precedence anyway, so that thing doesn't matter. So yeah, it's going to be all for this one. Hopefully you liked it. If you did, please like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching.